Okay, tonight what we're going to be talking about is how do you dilute a solution? Okay, so a dilution in dilutions, which is exactly what you think it is. It's like if you have a diluted substance, it's not as concentrated as it used to have. It doesn't have as many particles. Um, in dilutions, the amount of solvent, so the component in the greatest amount, so we're talking about, like, once again, the water typically in this class is increased, but the solute, so the salt or the solid that we dissolve something in, is kept the same. The result is a lower concentration. When we're talking about concentration, we're talking about that solute. So the molarity of everything we're talking about is the concentration of that solid that we put in, but it has a greater volume. Okay? So note that the moles and mass of the solute does not change for dilutions, okay? All you're doing is you're keeping the same amount of moles, but you're increasing the amount of solvent, so therefore your concentration goes down. All right, so let's look at this visually. So we have a concentrated solution on the left and a dilute solution on the right, okay? If we look at the concentrated solution on the left, if you look at the solute particles, which are the blue particles, there's a bigger ratio of the blue particles to purple particles on the left. That means it is concentrated. So when we're talking about concentrated, we're talking about what is the ratio basically between solute to solvent particles. In a dilution, what you're doing is you're adding more of that solvent. So if you look at the ratio between them, it has gone down for the solute. Okay, so this is a more diluted solution. So notice that the ratio of solute to solvent has gone down. So that is a dilute solution. All right, looking at this one, this is another visual. This is an emphasis on how the number of particles of your solute stays the same from the concentrated solution, which is on the left, to the dilute solution, which is on the right. All you did was add more solvent particles. Okay, so the solute stayed the same, but your solvent went up. So therefore, your amount of concentration went down. All right, there is one formula for that one, for a dilution formula, and that is M1V1 equals M2V2. M stands for molarity, as it always does. V stands for volume, and it's not a specific unit. The key for dilution problems is whatever unit you have for your volume on the left, it is going to be the same as that on the right. So if I use milliliters, that's fine, but my volume on my right had better be in milliliters. If I use liters, that's fine, but it better be on each side as liters. Okay, it doesn't matter which one you use as long as they are consistently the same for that individual problem. It also does not matter which one you assign as M1 or M2 and V2. Okay, typically the M1 and V1 are the more concentrated ones, and the M2, V2 are the more dilute ones, typically. That's not how you spell dilute, but that's okay. But it doesn't matter. What matters when you use this formula is you combine the correct molarity with its correct volume, and then the same vice versa for the other side. So you make sure that you partner up the molarity with its correct volume. So notice that these are both ones. So this is the volume of that solution with that molarity. Okay. So let's try to do a problem. You have 22.5 milliliters of a 2 molar stock solution. So first off, stock solution means it is your concentrated solution. So this is your most concentrated solution of CuSO4, and you dilute it to 250 milliliters. What is the concentration of the final solution? Whenever you see this word of right here, that is possession. So what that means is you have 22.5 milliliters of 2 molar. So what that does is those are partners. Those go together. So I'm going to make these my ones. So my M1 is 2.0 molar, and my V1, I'm going to stay in milliliters, 22.5 milliliters. Why? Because I noticed that my other volume's in milliliters, so might as well. I am trying to solve for my M2, and my final V would be 250 milliliters. Okay, so when I solve this, I get my molarity of 0.18 molar rounded to the correct number of sig figs. What you want to logically think about, though, is does it make sense for this to happen? If I have the same number of particles, of solute, I go from a 2 molar solution where I only had 22.5 milliliters of solution, and I added enough water to make it up to 250 milliliters. So does it make sense that my molarity went down when my volume of the overall solution went up? And it should. Okay, it should go down. And does it go down? Yes, it was started at 2 and it went down to 0.18. So that makes sense because all I'm doing is adding more water. So I'm making a more dilute solution of my CuSO4. All right, what is the final volume of a solution made when 380 milliliters of 0.48? So notice that that's possession, okay, is diluted to a final molarity of 0.2 molar. So I'm trying to find the final volume of that 0.2. So I'm going to partner my 380 and my 0.48. So it's going to be 0.48 molar times my volume of 380 milliliters. That equals my molarity, okay, of my final molarity of 0.20 molar, and I'm going to try to find my final V. So when I solve for V for this one, I get 912 milliliters. Rounded to 2 sig figs, it'd be 910 milliliters. All right, and looking at my units, does that make sense? If my molarity goes down, but I know I have the same amount of particles, what should happen to my my volume? Well, it's got to go up. Okay, so that makes sense. So 910 makes sense. All right, and the final one is how many milliliters of a 0.48 or 0.85 molar solution do I need to make 400 milliliters of a 0.2 molar? So in this case, this is going to be a dilutions formula where you're going to have to make solutions. This is going to be a typical one that you're going to have to try to solve for. In the end, I know what I need to make. I need to make a 450 milliliter of 0.2. So that's my final stuff. So in this case, I'm going to put 0.2 molar, and my final volume is 450 milliliters. Okay, so I need to dilute this solution. I'm trying to figure out if I have 0.85 molar solution, how many milliliters of that do I need in order to be able to dilute it to 450 at a 0.2 molar solution? So what you're going to do is 0.85 molar times my V1. When I solve for V, I get 105.88 milliliters, which means rounded to 1 sig fig, actually, it's 100 milliliters. So does that make sense that I would need 100 milliliters of a more concentrated solution to make 450 milliliters of a less concentrated solution? And it does. So this would make sense as far as mathematics go by and what I put together. All right, so that would be my final answer of 100 milliliters. All right, hopefully you kind of have a basic understanding of how dilutions work. Have a great evening.